going on a random walk. Come with me. But what is a random walk? In mathematics, a random walk is a stochastic process where an object takes a series of random steps in a mathematical space. It applies to all sorts of entities, from small particles to large organisms. For example, when time stops and I stand here, I am in a state space. But when time flows, I randomly take a step away from my original state space and into a new one. The movement of a random walker from state space to state space with different probabilities is called a Markov chain. In this symmetric random walk, the dot in a one-dimensional plane has a 50% chance to move one step left or right from any point on the number line. If you make that number of steps infinite, it creates a surprising trend. A Gaussian distribution graph instead of an aimless graph like this. The correct graph tells us that the dot will probably end up back at 0, or at most the square root number of steps taken from the origin. We can think of a 2D random walk as two lower dimensions. So after walking through this door, instead of having two transition probabilities with a 50% chance like before, I have 4 options with a 25% chance to end up at each location. Remember those Markov chains we were talking about? The Markov property states that after the dot goes into a state space, it won't remember the path it took to get there. You could say that every state space the dot visits is the origin and it will always return there, making 2D random walks recurrent. But 3D random walks are not recurrent since the dot can travel in 6 directions.
Examples of 3D random walks can be seen in the collisions between particles in a fluid. Einstein used this process to prove that atoms exist.
These movements can be seen in the stock market, natural animal behavior, diffusion processes, and genetic drift. So remember, the next time you go out for a random walk, you'll always end up where you started.